Hello and welcome to helpyourmath.com. In this video, we are going to talk about what it means to factor polynomials and factor by finding the greatest common factor. First up, what exactly is factoring? Factoring is when we write a polynomial as a product of its factors. With just numbers, we call this the prime factorization. So you might have seen this before. There's a bunch of different methods you can use, but it's like taking what's called a composite number, such as 45, and writing it as a product of its prime factors. So 45 is 3 times 5, or we can say 3 squared times 5. With factoring a polynomial, previously we've looked at simplifying using distributive property, maybe we call it FOIL. Simplifying would look like this, where we have x plus 3 times x plus 5, and then we distribute, and we end up with a final answer of x squared plus 8x plus 15. That would be either simplifying or multiplying, distributing, any one of those things. So going this direction, these would be called the factors, and this would be called the product. When we factor, we're given the product, and we want to identify its factors. So we're given x squared plus 8x plus 15, and our goal is to write it as x plus 3 times x plus 5. So when we go this way, when our final answer looks like something that wants to be multiplied, that's when we're done with factoring. We're going to look today at factoring by factoring out the greatest common factor, which I will forevermore refer to as the GCF. So when I say GCF, greatest common factor is what I mean. This is the first method that we're going to look at, and once we know it and love it, we always have to check for it. A greatest common factor is the largest factor or the largest divisor that goes into each given term. For numerical GCFs, you may recognize it because you know some times tables, or you can use a number of strategies to find it. So for example, if I said find the GCF of 4 and 6, so we're looking for a number that goes evenly into 4 and evenly into 6, you would tell me the GCF is 2, because 2 goes into 4 twice and 2 goes into 6 3 times. I could even give you 3 numbers and say, what's the GCF of 9, 3, and 15? And in this case, you would tell me that the GCF is 3. So yes, the GCF can be one of the numbers that are given, that is allowed. If we're looking for the variable GCF, if all terms have that variable, then it would be the variable with the smallest exponent. So if we have x to the 5th and x to the 11th, the GCF of those two terms would be x to the 5th, because x to the 5th is a factor of itself, and we could write x to the 11th as x to the 5th times x to the 6th, which would be factor times factor. The GCF of the GCF of p to the 4th, p to the 10th, and p, well, this p over here has an exponent of 1. 1 is the smallest of those 3 terms, so it would just be p or p to the 1st. To factor out the GCF, so now we know how to find a GCF, what we're going to do when we're given a polynomial is we're going to identify it, we put it in front of parentheses, and then we put what I call the leftovers from each factor in a set of parentheses. So just kind of using these as examples, if we had 4x to the 5th plus 6x to the 11th, we would say the GCF, so the numerical part of the GCF is 2, and the variable part of the GCF would be x to the 5th. So when we factor this, we take the GCF and we put it out in front. So out front is the GCF, and then we're going to put in parentheses whatever it would take, whatever's left over from when we remove the GCF from this using division. 4 divided by 2 is 2. X to the 5th divided by x to the 5th is just 1, so 2 times 1 is 2. 6 divided by 2 is 3. X to the 11th divided by x to the 5th would be x to the 6th, right? That's over here. Or we could do its subtraction because it's same base division. And then we close the parentheses, and these are what I refer to as the leftovers from each of the original terms. This looks like something I would want to multiply, so this would be the final answer. And the nice thing about factoring is you can always check your work because you can always multiply it back through and make sure you end up back with what was given, that 4x to the 5th plus 6x to the 11th. Before we look at some examples, just two more things about factoring. The first one, if we cannot identify a GCF among all the terms besides one, for right now, until we look at other techniques, we would say it cannot be factored. So if we had 4x to the 5th plus 7y squared, well, 4 and 7 don't have any common factors besides 1. And x and y, as far as we know, don't have any common factors. So if we had something like this, we would just say that this polynomial cannot be factored. One other thing, if the first term of an expression is negative, we would also factor out a -1 in addition to the GCF. So looking back at that last example, if we had negative 4x to the 5th plus 6x to the 11th, when we do the GCF, we would also include, where am I going to write that? Right here. We would also include a negative. We don't like the first term inside the parentheses to be negative, so we want to make sure that if the first term is negative, we're factoring out a -1 in addition to a GCF. So here we would factor out a negative 2x to the 5th because 2x to the 5th is the GCF. Then when we divide, we're going to divide them both by negative 2x to the 5th. And this would factor into, well, we have the GCF out in front, negative 2x to the 5th. Negative divided by negative is positive. 4 divided by 2 is 2. X to the 5th divided by x to the 5th is 1. And 2 times 1 is 2. Positive divided by negative is negative. 6 divided by 2 is 3. X to the 11th divided by x to the 5th is x to the 6th. So this would be our final factored answer here if we had the first term negative. Notice that the signs are now changed from what was given. We had negative positive, we factor out the negative, and now we have positive negative. And then just combining these two quirks, if -1 is the only thing that we could factor out, we would do that. So even though, it sort of can't be factored, we would still take the step to factor out the -1. So that's if we had negative 4x plus 3. Even though the GCF between these two terms is 1, we would still go ahead and just factor out a -1 and write this as -1 times, and then that changes the signs, 4x minus 3. Or you can drop the 1 and just say negative 4x minus 3. 1 is the multiplicative identity. So either way, if you want to keep it, you can, to say this is going to be the negative of this binomial, or you can just write the negative. All right, let's look at some examples. In our first two examples, we want to factor by finding the GCF. Looking at the first binomial, it's a binomial because it has two terms. 6 and 42 are both divisible by 6, so we'll factor out the 6. That means we're going to divide each of these by 6 and take that GCF and pull it out in front, leaving behind 6y divided by 6 is y, 42 divided by 6 is 7. Notice when I write the leftovers, I normally keep the sign that belongs to it unless I factor out the negative. So it was minus, inside the binomial stays minus. This looks like something that wants to be multiplied, and this would be all done. In the next example, I see we have that negative term first, so I want to make sure I factor out a negative. 14 and 21 are both divisible by 7. I have an x cubed and an x, so this would be x to the first. That would be the smaller of the two base x's, so I'm going to factor out an x, and then they both have y to the first, so y is part of the GCF. I'm going to divide each of these by the GCF, negative 7xy, negative 7xy, and then I put the GCF in front, and when I divide, I put the leftovers inside the parentheses. Negative divided by negative is positive. 14 divided by 7 is 2. X cubed, I had 3 factors of x. I'm dividing out 1. That leaves me with x squared. And then the y's will cancel because it's y divided by y. That's 1. 1 times 2x squared is 2x squared. Second, we have a negative divided by a negative. That's positive. 21 divided by 7 is 3. The x's cancel and the y's cancel. So it would be just 2x squared plus 3 are the leftovers, with the negative 7xy out in front as our GCF. I encourage you, before I do these, to pause the video and see how you do with these two. Okay, in our first one, oh, it was so close, right? We had the 4x cubed and the 12x squared, and then, oh, there's no x. So in this case, we would just focus on the numbers 4, 12, and 28. And those are all divisible by 4. I'm going to factor out a 4. First term is positive, so we're all good. I'm going to divide each of these by a factor of 4, the GCF. Leaving behind, 4 divided by 4 is 1. 1 times x cubed is x cubed. In the middle, negative 12 divided by 4 is negative 3, and it would be negative 3x squared. And then 28 divided by 4 would be 7. And that would be all we can do here. We put a box around it. Wants to be multiplied, but that means we're done. In the next example, the GCF here, so the numerical GCF, 8 and 12, are both divisible by 4. We have an x squared and an x. We're going to factor out an x. A y and a y squared, we'll factor out a y. We're going to take that GCF. We're going to divide it into both terms, divided by 4xy, divided by 4xy. 8 divided by 4 is 2. X squared divided by x, there were 2. We're going to divide out 1, so that leaves behind one factor of x. The y's cancel. Negative divided by positive is negative. 12 divided by 4 is 3. The x's cancel. I had 2 factors of y. I'm dividing away 1. I have 1 factor of y left. So we have 4xy times 2x minus 3y. We're going to take this up a notch in our final 2 examples. The first one, we have 5t squared minus 9. In this case, the GCF is it's 1. So it's 1. The first term is positive. There's nothing else we can do. This one cannot be factored. Okay, now for this last one. This one's kind of funky. This one has 2 terms. So this one's term 1, and this is term 2. Term 1 has 3 factors, 2, m, and m plus 3. Term 2 has 2 factors, negative 7, I guess technically 3, because we have negative 1, 7, and m plus 3. The GCF here, hear me out, is one of those factors. The factor that they both have is the m plus 3, right? This is a factor because it's the only thing happening to it in this first term is it's being multiplied by 2m. It's a factor of the second term because it's being multiplied to that minus 7. So that is the GCF. We pull out the GCF just like we do with any other question, and then we divide it into each term. When I divide it into the first term, what am I left with? Well, there's still a 2m there. When I divide it into the second term, what am I left with? The minus 7. And this would be our final answer here. M plus 3, the GCF, times the leftovers from the 2 terms, 2m minus 7. This has been an introduction to factoring and factoring by finding the greatest common factor. Thank you for stopping by.